I'm a 36-year IBM research guy. I've also been the IBM India chief scientist for about 3 years. I was based in Bangalore. This was from the middle of 2006 to early 2009. I'm what they call an IBM fellow, meaning I've been a technologist all my life. In fact, there are fellows who are managers, but I chose to be a non-manager my entire career. And this lab is where relational databases and SQL and hard disk drive and all that came from. So it's an extremely well-known lab in San Jose. And I also happen to have this honorary position at Tsinghua University in Beijing. And I'm, in fact, headed over there on Sunday. So unlike Alex, I spent less time in the blockchain space, about 1.5 years. And I come from the database angle, so I can say a lot about that statement that was just made, that it's merely a distributed database. There are quite a few differences. If I don't get around to talking everything that I would like to talk about, feel free to go look at this URL. If you get my business card, that URL is also in that card. There you will find a lot of links to PowerPoints and videos and all sorts of stuff like that, including papers, both research kind of papers as well as more white paper kind of industry-oriented things. And I keep updating all this with new information as I keep giving presentations and so on. So hopefully I won't doze off. I just came back from a 2-week trip to Europe on Sunday evening, and so I'm still conked out from my jet lag and everything. What else do I want to say? I think that covers it. So I can skip some of the things since Alex has already covered the material with respect to public blockchains. And of course, he phrased a lot of the things in this half full, half empty way. He didn't tell you the negative aspects of all the good things that he had to say about the public blockchains. And hopefully I'll get around to saying that. So, but I'm going to skip some of this introductory material since he has already covered that. And so that'll give me an opportunity to say more things about the rest of the story. This is the full-blown presentation. Unfortunately, I don't have the time to cover it. So if you go look at the videos, some of them are long enough that I have spent time covering some aspects that I won't be showing the slides of. By the way, you will see that the slide numbers sometimes will skip, and that's because the full set of slides is in this presentation. So if you look at it in the non-screen show mode, you will be able to look at the material that covers some of the topics here that I won't be covering explicitly in this presentation. So just to, this is the kind of thing that would have been a lot better with less light, but I got argued out about, especially for the people sitting at the back. Unless my classmate there has much better eyesight than I have, I won't be able to see from there whatever this thing says. To give you an idea, some of the things that had to be brought out only through questions, the performance of public blockchain stinks big time. In spite of what Alex said about even Ethereum, that's all a futuristic kind of statement, what he said about 10 seconds or something he claimed. Really, they are also using proof of work. They are talking about using proof of stake and such. But in any case, fundamentally, I have a lot of problems with this whole notion of public blockchain and any joker anywhere, willy-nilly coming and going and all that. It just doesn't scale. In spite of all the fancy things that algorithms people might come up with, there is no hope of that thing ever having the kind of scale that you can have with a private blockchain. And more importantly, this whole notion, what you call transparency is a double-edged sword. Do you want really the whole world to know what the heck is happening? It's kind of crazy. This whole thing is madness. In fact, even in a private blockchain, we have been forced to introduce extra measures so that not everybody that's in a private blockchain gets to see everything that's going on there. Because if you have Safeway and Walmart in the same blockchain with their suppliers, Safeway doesn't want Walmart to see, what its traffic is and what transactions it's doing with whom and so on. So at various levels of real-world concerns, this whole notion that everything being visible to everybody and anyone anywhere can just willy-nilly come and go, and also this thing forever is expanding, and as new guys come in, they take forever to catch up to the state and so on, especially if you're now talking about Ethereum kind of situations where there is a state being maintained in every one of the nodes. The way I would have phrased it is there are assets that are being managed, and it's the latest state of these assets that's in that state database. The blockchain contains the transactions which were transformations to those asset states, but the latest state of these assets, just like in a database, are cached in the state databases that are in the nodes that are part of the network. And the way a new node initializes its state is by starting from day 0 and processing the bloody log all the way. And that just is not going to scale as time goes on and more stuff gets into that blockchain. And so for various such reasons, the scalability is a big problem, as well as privacy and all those sorts of issues. And this whole notion of creating something out of nothing and all that, the cryptocurrency part also I don't buy into, because this is like, I would rather have as somebody was questioning GDP and all that, have a role to play in with the money supply than some algorithmic geeks like me and other people deciding, how many coins should be there and making it a highly speculative thing and things like that. So if you are into gambling, feel free to do all this crypto stuff. But otherwise, I would rather go with digital representations of fiat currencies rather than a lot of these people thinking they're going to settle all the world's ills by coming up with something that they thought would be adopted by everybody. And this is like Esperanto language being invented with the hope that all the linguistic problems of society will be settled because everybody will use a single language. And we know what happened over there. So it's totally unlikely. And as was mentioned, there are already gazillion of these cryptocurrencies anyway. So it's not like Bitcoin was going to be the only thing that will take over the whole world, and all the problems of fiat currencies will be fixed by this. This has introduced its own set of problems. So I'm not going to waste too much time actually delving into those aspects. I've had enough arguments with people who are on the other side of this whole discussion and debate. But in terms of what's going on, there are all sorts of organizations working on various aspects of public blockchains in particular, although there's a cottage industry behind also the public blockchain topic. That's university people as well as Silicon Valley, startups and VC kind of people who are funding those activities. But in my opinion, the more productive thing to be doing is the private blockchain. And we will discuss more details of that. So there are people working on the security, consensus, database, and benchmarking and verification aspects. The verification has to do with how do you take an English language or some natural language oriented contracts and create something more formal with it and then prove properties and then go from that to an executable contract and things like that. In terms of how real is all this, there has been a production deployment since about a year ago, which was the version 0.6 of the Hyperledger fabric, which was used to do private equity funds management in Guernsey Island. The important point to note is it's still not your father's transaction processing council kind of benchmark-oriented workloads that you can deal with using this technology. It's not millions of transactions per second by any means. And so the private equity has the property that the value of each transaction is high, but the number of such transactions is low. So it's those sorts of arenas where we will see wider adoption of the blockchain technology, not in the cases where traditional OLTP kind of systems are cranking away millions of transactions and such, which is the norm in the kinds of businesses I've dealt with all my life at IBM before I got into this business just a year and a half ago. I'm still a database guy in my core. In terms of, what all companies are going after this, if you hear somebody saying, oh, only IBM cares about it, total BS, because there are any number of companies now that are firmly behind this whole private blockchain business. The Chinese especially, for instance, they are now going gangbusters on this kind of stuff. Not all of them have fully described what they are up to, in the sense that some of them have only released Chinese language versions of their white papers and so on. They seem to be initially targeting the Chinese market. But Oracle, for example, announced in October that they will soon be coming out with Oracle Blockchain as a Service offering, which IBM has had for a year now, both based on version 1 of the Hyperledger Fabric. I've been told that in the next few weeks, the Oracle one will come out. And so there is, as a result, quite a bit of momentum behind the Fabric. Baidu joined as a premium member of the Hyperledger Consortium. They have announced something, but it's not quite clear. It's very hard to parse some of these people's statements about exactly what product offering they're having and what it's based on. But my current very educated guess is that I have even had to pull, Chinese statements and then stick them into Google Translate to figure out what the heck it's saying. But I believe they're also going to be having an offering, blockchain as a service offering based on version 1 of the Hyperledger Fabric. Huawei, just in the last few weeks, announced a blockchain cloud service, but again, initially they are targeting China. The market is expected to be pretty large. IBM in its offering, just to settle this point about, anybody could screw around with it just because it's a private one. That's very naive kind of statements. The particular offering that IBM has got runs on the mainframe running the Linux operating system, and it makes use of the most advanced features in the hardware for not only improving performance with hardware support for encryption and so on, but also secure execution environment, which is far superior in many ways to what Intel has with its SGX offering, which is a secure execution enclave, where even the operators of the systems cannot tamper with the code or look at the data that's being manipulated as part of the smart contracts and such. By the way, I forgot to say it, my IBM colleague Shweta, she can wave her hand, she will be coming up here, hopefully not too far into the future, and demoing some of the things that I'll be talking about. And she's going to make sure I shut up at the appropriate time so that she gets a chance to show off the technology that I'll be talking about. But I'm going to cover more than just the Hyperledger Fabric, by the way. So this is not intended to be like a marketing pitch or anything. What else? There is benchmarking related work also, just like the TPC benchmark that has been around for a long time for various types of database workloads. This just got kicked off as one of the newer projects in the Hyperledger Consortium just a few weeks ago. It's called Caliper, but there's already a research community piece of work that was done at the ACM SIGMOD conference in June last year, which is the world's first benchmarking framework that the National University of Singapore people initiated. It looks like somebody from Singapore is here. So there's quite a bit of stuff I'll refer to about that. In terms of the various technologies that are at play here, there's a long list of distributed systems technologies as well as database technologies that have a role to play with respect to a blockchain. So it's not like it's completely, unconnected to traditional ways of doing business. Far from it. If people haven't done their homework, guess what? Byzantine agreement protocols were being worked on in my lab 36 years ago when I joined the lab. And I myself have worked on many of these technologies that are listed here long before the rest of the world started thinking about Byzantine kind of behavior where somebody can intentionally try to screw up the system, as opposed to the normal kinds of failures that the Mohan kind of people have dealt with forever, which is a node failure which results in the main memory contents getting lost, or a persistent store failure where disk drives contents can get lost, or link failures which can result in network partitioning and so on. Somebody here asked a question about this, something like network partitioning, how is that dealt with in this context? There have been various other things that have happened over the decades, like messaging and queuing and so on, as well as, much more importantly, workflow management or business process management. They all have great deal of similarities to what's happening with private blockchains in particular, but it also applies to really even public blockchains with smart contracts and such. In the same spirit, the database kinds of things are also very relevant, being able to do analytics on the blockchain data, whether you have to extract the damn data out of it and stick it somewhere else to do the analytics, or you can do in-place analytics, which is very important these days, the so-called HTAP systems, hybrid transactional and analytic processing, as opposed to OLTP system here, and then you periodically extract the data and shove it somewhere else and do analytics on the OLAP kind of system, which is considered old-fashioned these days because you want the analytics on the latest and greatest state of data, not on some old version of the data. So if you look at a scenario like this, which Alex talked about, export-import scenario, there are way too many players, and there are still, paper kinds of documents being used. Even if they're all communicating with computers and messages and so on, it's typically point-to-point communication. Each of the entities has its own database where the states are being tracked, and there is no single source of truth. And so there can be a lot of misunderstandings that are not obvious. You order something until the order comes to you, the fulfilled order comes to you, you don't realize the person misunderstood your order, and then there's a lot of back and forth about who pays for the damn thing to be sent back and reconciliation and all this kind of stuff. So this leads to a lot of inefficiency, expensiveness. Of course, not all of this had to be that way. People got away with murder. He was talking about how it costs so much money to transfer money from one account to another account in a different country. They got away with it, so they've been doing it, and they use the float and all that. It's not like fundamentally it had to be that way, that you had to have blockchain as a way of doing business for it to suddenly become ultra efficient. Zoom actually, even before I hit the return key, I get a message back saying my money is in my HDFC account in India. So it can be done. It's not like all of these things necessarily require the brand new technology. Sometimes people are getting off their rear end and doing new things just because they want to get into this new technology, not because that's the only way to do it. But in any case, this kind of scenario, the other problem is that if something goes wrong, people go after the fact, modify original documents to try to shift the blame onto somebody. So a lot of those sorts of problems is what we are now interested in fixing by using the blockchain way of doing business. But this is still in a domain where we are interested in only the parties who have a business reason to be interacting with one another to then get into the act and be part of a network, not some silly guy who has now the job to do. Some random guy somewhere who has a laptop or whatever, and he just willingly comes and joins the fray. That whole notion that the public blockchain has, in my opinion, is totally impractical, and it doesn't make any sense whatsoever, that people can randomly get into the act. And what do they have to do about verifying transactions and all that in the most general sense? Just doesn't make sense. So the point here is that you have a single database in which you are in a more systematic way going to be doing updates, and this single database is a replicated database. So it's a single source of truth. And so a lot of the things that have to do with why things will be better here compared to, let's say, the traditional way of doing has to do with the fact that there is a more orchestrated way in which the different parties to the transaction will be playing a role in determining for the assets that are being managed what the legitimate state transitions are, when, who agreed to what kind of transition being done, and such things get recorded in the blockchain. Some people get a little confused about this immutability. They think, oh, the databases used are not doing in-place update. Far from it. The immutability has to do with only the blockchain data structure itself, which is an append-only kind of ledger, just like in any kind of banks and so on. I mean, if you deposited a check for $1,000 and it got wrongly credited as $100, you later on go scream at the bank, then what are they going to do? They're going to put a new entry saying there's a correction to that old entry. They don't go change the original entry itself. That's exactly what it is. But the database which contains the state of the assets being managed, that is pretty much an in-place updating traditional kind of database. So in many ways, the blockchain is not all that novel. If you think of databases and recovery, the recovery log in a traditional database system, not some of these half-assed database systems called NoSQL, which don't have all the traditional strength and this and that industrial strength features. The recovery log, which I've spent my entire life working on, is an append-only data structure. We never do in-place update in the recovery log. The additional things that the blockchain has, which we will talk about, has to do with all this, having the hash and this and that. And also, we record more in the blockchain than in a typical recovery log, and we'll discuss that later. So it's this way of doing business where also you have signatures and such so that parties cannot later on claim that they didn't agree to a certain state transition being done. That makes it different compared to what a traditional recovery log has, and also compared to traditional workflow management systems or business process management systems. They didn't take as seriously this whole notion of leveraging cryptography and certificates and so on to, in a more provable way, record things so that nobody can later claim they didn't agree to something. And also the workflow management systems, I had a project on that thing, so I know quite a lot about that topic eons ago, actually. They didn't take seriously this whole notion of doing things in a distributed way so that failure tolerance and all that can be much better. Yeah.
I have a question. When you talk about databases, right, and bringing the whole crypto aspect of the database,
right.
I talk about fundamentally certain parts of a database exposing so-called crypto type or whatever, or you're still treating the database as a primitive stuff that you can put whatever you want, and then you're layering something on top of it.
It could be all of the above. It all now depends on what kind of a database system you use. As you will see soon, in the case of the Fabric, it's not my decision. Some set of people decided they'll use something called the level DB, a key value store, which is unbelievably dumb, unbelievably primitive. Shame on us that, okay, this is all being recorded, so I better watch it. We invent relational, and then we go support this key value store, which is even worse than pre-relational things like IMS and VSAM, where at least you have a primary key and then individual fields, which you can refer to in queries as well as data manipulation statements. Whereas this key value store, you have a primary key and then a bag of bits. The interpretation of the bag of bits is left up to the application writer. This is so error-prone, all this kind of stuff. So the smart contract is the one which knows the interpretation of all that. So that introduces a whole host of problems. But I'm actually currently working on a project to support relational databases as the state database in the case of the Fabric, in which case you will have the power of whatever the features are that the relational DBMS has, where you could have field level encryption, field level authorization, and all sorts of features like that. So there isn't anything cast in concrete about where you do what you do and what set of features you support. And that's, in general, a statement that needs to be made, that at this stage in life, there isn't something like a SQL standard for the blockchain world. We are in the blockchain space where relational systems were 40 years ago. It's even worse than that, because at least there, for the most part, SQL became the lingua franca without even a formal standard having been established at that point. Yeah, there was Quell in Berkeley with Stonebreaker and company doing it for Ingress, but they lost out ultimately in the battle for standardization with IBM's SQL becoming the standard. So in that sense, there is more chaos now, because unlike in those days, even with Quell and SQL, where at least the conceptual model was agreed upon, which was a relational model as Ted Cord had proposed it, my colleague actually, in my lab. Here, even at the conceptual level for these private blockchains, there isn't a standard. And so there's a lot more chaos now, but it's not as bad as the NoSQL chaos where every company has its own API. Here, at least, the work is being done in the form of consortia. The number of consortia is much smaller than the number of NoSQL kind of organizations. Yeah.
Some of your thoughts on, you talk about the NoSQL nonsense.
Right.
At some point, please talk about the tap theorem. What are your
yeah. This could be an orthogonal discussion, but yeah.
Just to add another question, but to build upon this question, so you said relational, so also it has some abstraction of object relational also, I assume?
Well, it all depends on what you want to be the programming paradigm for the writer of the smart contract. At this point, I would rather leverage the existing SQL knowledgeable people and the ability to model the assets that are being managed in much more flexible ways than what, let's say, the key value store paradigm allows. But even object relational, we spend a lot of resources doing all that, but it didn't really take off. So again, that's something we can have an orthogonal discussion over lunch or something.
The question I had was about, you said about the fact that the public blockchain is just not a practical thing, so it's not only a performance issue, it just doesn't even make sense. Like
Yeah.
Walmart example and all
Yeah,
that.
exactly.
So
From a privacy perspective, all sorts of such perspectives, I just don't get it. I mean, it's all nice and dandy to talk about, democracy, this, that. Do you really want the village crowd getting around and deciding what the punishment should be for some crime committed? I would rather have knowledgeable people, making the call than willy-nilly just because some people have resources. There are server farms up the wazoo in China, right? I mean, this taking over can be done, actually, if people put their mind to it, just like we have seen with all this election fraud and all that. It might not be a big deal if somebody is hell-bent on creating chaos for them to devote even one country worth of electricity to do this, if they are hell-bent on creating trouble. So this democracy by itself, I don't buy into. And also this whole ICO thing, I've been in the Valley 36 years, so I know what happened with counting eyeballs and all that during the dot-com era. So, yeah.
Yeah, I just had an addition to you said that, Hyperledger fabric using level of functionality, it's a NoSQL database. But I think there's another framework called Borda, which I think uses relational database.
Yeah. So we'll come to that. My point was very specifically about the fabric. I wasn't saying all of them. Okay, so we are sort of getting ahead of the game. So I have all that material here. Okay, so this is just showing you what the IBM blockchain platform has, which is the blockchain as a service offering. It's pretty much, by the way, the other confusion, I can't believe the number of people who have this problem. They think open blockchain means open source. Private blockchains means private code. This is a totally bogus statement. This has no basis whatsoever. A lot of these private blockchains are actually open source projects, specifically the everything under the umbrella of the Hyperledger consortium, for example. And we will discuss some of the others also. So in that sense, you can do all this yourself, but if you want a managed service offering, that's what this is, where you have to pay money. But if you want, you can download the Hyperledger Fabric and the Hyperledger Composer and run these things on your own machine or whatever, on a public network if you want. But if you want the one from IBM, it has some additional features which are not part of the open source offering, which has to do with all this operational tools and this and that. This is the one that I said runs on the mainframe. Just like you have in a database system, whole bunch of roles like DBA, system admin, and application programmer. Here you have many newly defined roles, which are like the blockchain user, the blockchain architect, the blockchain developer, the network operator, which in this case is IBM. Soon, Oracle and Baidu and all these guys have their own things also. And you also have membership services. Because it's a private blockchain, you have to be admitted to the party before you can participate. And the price of admission is you have to reveal your identity, you have to get certificates, and so on. This whole notion of pseudonymous, it's led to all sorts of illegal things being done using all these open blockchains, drug trafficking, to all sorts of stuff like that. And do you really want to use Uber-like service or Airbnb if you have no idea who the person is that's at the other end? So even at that level, you do want somebody to be held accountable if they misbehave. And so at least in the case of Uber and Airbnb, those companies know who the heck these people are. Even if you and I as the users don't know the whole history of those people, the companies know. So if they misbehave, and there are times when they've literally tried to get away with murder and all that, they've been taken to task. So in general, this notion that anonymity is good is just not, unless you are really seriously interested in doing some illegal things or whatever. So at various such levels of discussion also, there's a lot of problem with this, things being at the end of an address. And then if you lose, you are screwed. You don't have a way to appeal to any authority to get any kind of resolution of stealing and such things that also have been talked about. So in this context, this membership service is the one which deals with issues like dealing with organizations being made part of the network, as well as individuals within the organization who are these blockchain users. So you do have to distinguish between organizations being treated as peer nodes in the network versus end user type people within those organizations who are acting as clients at the client machines. And you still have the connection to traditional backend systems, be they database systems or invoking functionality like SAP and so on. So you might, for instance, accept an order through the blockchain, but the fulfillment of the order might still involve having to go and use your existing ways of manufacturing the particular item or whatever. And so that's why this part is also still a relevant thing. But it is the case that in order for you to benefit from blockchain technology, if you were in that messed up state where individual nodes had their own programs which were doing whatever they were doing, and you want to get to this more systematic way of doing things, you do have to rewrite your existing applications that are dealing with these multi-party interactions and so on. So there is no free lunch here. You cannot think, oh, I just roll in this new piece of software and suddenly, life is all bed of roses. And without any other pain having to be suffered, you will get the benefit of blockchain technology. So there are, various approaches that have been adopted in the systems that are around now as to how you go about doing this re-architecting of the existing pieces of software and so on. I had a slide, but I don't know whether I still have it or I hid it. But before I get there, this piece of software called Composer, in case you didn't notice it. So you have the Hyperledger Fabric here, which is a base platform, on top of which you have this additional tooling, which is like 4GL tools in the case of database systems, which allows you to make use of the Fabric to implement solutions more easily. It's not like this is required. Composer is not required. You can go directly to the Fabric and do your things. But Composer, which is a relatively newer project under the Hyperledger umbrella that IBM also initiated by contributing source code to begin with. And then there are now other people also working on it, just like the way Fabric started. IBM initiated the whole thing. The consortium was formed with Fabric as the first project, actually. But then there are now other people working on it. So this Composer is the one that lets you define the various elements of a solution, a use case, that leverages, at this point, the Fabric. In due course of time, I can imagine Composer being made to run even on other kinds of blockchain platforms in addition to Fabric. So what are the elements of such a, this is like a database design, right? Now this is a blockchain solution design. What are the things that you have to think about? The assets that are being managed, whether it's diamonds or packages or containers and such things, or food ingredients that are in a farm to fork kind of application. Then what are the transactions that you're going to be having? These are the pieces of code that will do transitions on the assets that are being managed. So in the case of diamond, it was mined. You have the raw diamond. You send it for polishing. Then you split it into multiple smaller diamonds. And then you do wholesale, retail sale. And then a single diamond gets mounted on a ring. And then somebody proposes to somebody. This is the whole workflow, if you like, or the provenance of what all happened to this. And in the case of packages, smaller packages can be put into a bigger box, and then the multiple such boxes can be put into a container, and then when it gets shipped, and the other end, you now split it into the original elements, right? All of this needs to be modeled, and these transitions have to be also agreed upon, and there are transactions which implement the logic behind these various state transitions that these assets are going through. And also, by the way, there are all these participants, the organizations themselves, as well as individuals within the organization. This is all similar to databases where you have privileges to be able to invoke programs versus read data, write data, views and tables and all this kind of stuff. So there are similar notions like that. So the developer is developing the model with all these three different things and also writing the programmatic logic, which is the one that is now going to run in all the nodes which are participants in this particular business process. Okay? So that's the way in which more systematic way of doing things is being brought about instead of the chaotic way in which individual nodes traditionally have done these things while interacting with one another using MQ messages or EDI messages or XML formatted messages or more modern day thing that everybody gets excited about, JSON formatted messages and so on. Okay. Okay, so let's look at how a typical operation takes place in one of the peer nodes, right? This is not the full picture. You'll get the fuller picture later. So the client starts a blockchain transaction by essentially providing some input parameters to a smart contract that's on the server side. That's this box. That gets invoked. And as that smart contract runs, it'll make some database calls to read the states of the assets that it wants to manipulate. And also, it will do these puts and deletes. And this is where this simple-minded data model capability of this particular state database results in such calls being supported, get, put, delete. You don't see a familiar select, insert, update, delete of SQL or create table and alter table and such statements. In my project, that's what I'm currently working on. So the reads are sent directly to the database system, but these puts and deletes, they are cached by the fabric layer that sits between the smart contract and the DBMS. Because this is considered the initial stage of executing a transaction, which is a simulation of the execution of the transaction. So as the smart contract executes and the reads are performed, and the smart contract also might invoke other smart contracts, ultimately, when control is about to go back to the client, which designates the ending of that particular blockchain transaction, that's when this layer in between, which had been tracking these calls that were made database calls, it produces what are called write set and read set. The reads are the reads of the items that were performed with the version numbers of the items read. And for the writes, these are the intended writes. They are not yet performed because in parallel, multiple such nodes are being asked to simulate the transaction. The client will later receive all the results of these simulations and then do some things that I'll describe later. So in this stage, no updates are performed so far. The database doesn't even get to see the updates because they're all cached in the memory of the fabric layer that sits between, and it sends it back to the client when this call goes back. So the way this thing works, and some people asked this question before, you initiate a blockchain transaction. Much later, you discover, as in the case of Bitcoin, 10 minutes later and so on, what the heck happened to your transaction, whether it actually committed or not, and so on. And so typically, event-based way of doing this is what's needed, meaning you register for your interest in getting notified about certain events that are going on. As you see here, it says events are emitted when, let's say, a blockchain transaction starts or a smart contract gets invoked and things like that. And you can have distributed event notification kinds of activities being performed here. And so separate from the database is this blockchain data structure, which is, as was discussed by Alex, a set of blocks, unlike in the case of Ethereum and all this, where you have the potential for branching of a linear chain of blocks, and hence all sorts of confusion comes because there's non-determinism there. Multiple people can win this competition to add a block of transactions and so on. Madness, and that's why they unnecessarily wait for a longer time, hoping that your transaction, if it sits in the longer chain, probabilistically has a likelihood of getting ultimately the winner kind of designation. It's all still probabilistic, by the way. There's absolutely no guarantee with this open blockchain way of doing business that you have any assurance that what you thought was in the in the set of blocks that are in a block that had been added to the chain doesn't mean that you will necessarily be actually guaranteed that your transaction succeeded. Whereas here, typically, there is no such ambiguity because there is deterministic way in which blocks get added. And so, yeah.
I mean, the reason why you have ambiguity in the public blockchain is because of scale. You don't even know when the convergence happens.
Well, because of this whole notion of, oh, I'm going to make you solve a math problem, which by itself, by the way, is mind-bogglingly inefficient in this day and age of green consciousness and all that, because multiple people can simultaneously win that competition. That's one of the basic problems.
So you are solving some puzzle.
Yeah.
A puzzle could be in the Bitcoin, they made a puzzle to create a hash, basically solve a hash, right? Whereas in this context, right, what you're going to do essentially is you're going to do some matching and all those things.
Right.
And then that is the puzzle you're solving. Right?
But it's not a,
it's not a puzzle.
yeah. But this whole business of some random jokers, yeah, that's the whole point of my concern with the blockchain, the open blockchain way of doing it, and also the fact that it doesn't determine deterministically that one person is the winner. That's the other problem there.
But I think here is the client is making the call, is waiting synchronously for an answer, right?
No, it's not. Because I didn't tell you that you get to know the final story. This is only part of the story.
Okay, the question of what I want is whatever the work you're doing to solve, I mean, not a puzzle per se, to solve the transaction thing, right? That will scale will it have problem and the scalability comes in picture.
Well, so it's now a question of what are you going to have in your network? There are multiple networks. So in the real world, if you have a scaling problem, that probably will get reflected here. But so it's a question of what the real world situation is that you are dealing with. If you have 1 million suppliers in your network, then that could be a problem. But it's not fundamental to the solution itself, is my point. Unlike in the case of the open blockchain, where just because they said anyone, anywhere can participate and come and go also, at any given time, the question was asked about how do you even propagate the damn thing? This is all, very, very open-ended. This whole notion of how do people even find out what the heck is the current state of affairs is all based on this disease spreading kind of model, right?
It's anarchy, but beautiful.
See, this is the problem. There are way too many people who I'm a techie guy. Like I told you, preface the whole thing. I've never even been a manager, right? But I still have my limits on what I accept for the cuteness of it versus the practicality of these sorts of things. Yeah?
I have a question there. You said that, before it gets committed to a database, you have this transaction that's, stored in a fabric layer.
It's being cached. If you have heard of optimistic concurrency control, where in a private workspace you keep the intended updates until you know for sure that you have reached the end of the transaction and now you want to minimize the amount of time you hold locks and so on. But that's a totally separate discussion, but this has the flavor of that. But here the reason they do it that way is because they want to obtain consensus from a bunch of people who are party to a particular state transition that's under consideration. They're no different from the priest asking the boy and the girl, are you willing to marry, are you willing to marry, and then saying, yeah, okay, they are now married. It's similar in notion. Maybe you should wait for a bit, because I'll describe the fuller protocol, then you will have a better understanding of. We have the notion of endorsement in the fabric. That's what this is, just setting up the stage for arriving at this endorsed state of affairs by contacting multiple people simultaneously. Once you figure out whether they are in agreement or not, then you proceed forward with doing the rest of the things relative to performing that transaction. So it's the staged way of doing, where initially you are just figuring out what would be the thing that would be happening if this transaction were to be allowed to proceed forward.
What happens is that you are crashing.
We'll worry about, so all this is just in memory, remember. There's nothing persistent about this so far. So some transactions, yeah, they would have to be restarted.
Okay.
We'll come to that. Was there another one somewhere here? No? Okay. Yeah.
So this model cannot work for e-commerce, right? As of its present state, right? Because
Why?
Let's say if I'm giving an example of Bitcoin. Let's say I bid for buying something, or I actually made a transaction, by the time the transaction actually happens, the value has changed.
Well, that's like real life also. I mean, you look at something, we go through this all the time with airline tickets, right? They show you a price, and by the time you say, hey, give it to me, many times they come back and say, sorry, that price is no longer available.
Right, but most of the e-commerce transaction, let's say you have a defined price, you will pay and you will...
But that can happen here too. I mean, it's not like this is defining its own rules of engagement or anything. A lot of the e-commerce things today work on cached information. That's why you get into this mess with the airline seats and all that, right? When you go to Travelocity, this, that, they don't know for sure that the seat that they think is available will be available by the time you hit the return button and say, hey, okay, now that you've shown me the prices, I like it, go get it, and then they say, sorry, it's gone. The price even changes, by the way.
The airlines, you book with one airline and they say, well, this is a partner airline, it'll be 2 days before you find out if you have your ticket.
Yeah. So I don't think that by itself is an issue. I mean, there are any number of e-commerce kinds of things being done with this technology now. Anyway, so that brings up the topic of there are gazillion applications. Alex didn't tell you, there's this book that came out about a year ago, Father and Son Team. It characterizes the phenomenon of blockchain as having the potential to be the second coming of the internet. In terms of not you and I as geeky people getting to do things, but for the man on the street, it has the potential to dramatically change their lives is the point. And so if you look at these list of applications, which is by no means complete, and in the longer version of this deck, you will see other slides and so on. Good number of them are already in production deployment. I talked about the diamond example, that's Hyperledger, that now, as of a year ago, had actually 1.3 million diamonds or something that they were managing in a production way. And I've heard the CEO of this company talk about it. She's very excited. They are now using it for tracking even highly priced wines and things like that. There are more slides that I'll show you in case you are interested. Food safety, IBM had been working with Walmart in China on farm to fork kind of scenario. The idea is to track more carefully what went into making what and so on. And this can be also for cars and such, right? Spare parts or whatever, componentry. So that if something does go wrong, the recalls don't have to be en masse kind of recall. And so this can result in a lot of money being saved and things like that. And also, if the food got shipped in a truck and there was some problem with the air conditioner, and so that resulted in people dying and so on. It's harder with this way of doing business to, go do hanky-panky with the temperature reading and things like that in the documents that might have been produced. So there are many things like that where the blockchain way of doing things with all that hashing, that Alex talked about, makes it a lot more foolproof with respect to tampering and things like that.
Question.
Yeah.
So am I inferring that private blockchains do not use things like hashing?
They do.
They do?
Yeah.
So then how is the problem solved in terms of the ambiguity?
No. This hashing, okay, there is some misunderstanding. It's not the proof of work I'm talking about. I'm talking about in the blockchain itself, the way that data structure is managed, hashing being used. You are getting confused with the proof of work, which allowed, which determined who gets to add a block of transaction.
Right.
That's not,
so this
no.
is purely on the blockchain.
The data structure and,
okay.
yeah.
But if you control the private blockchain, you control the nodes, so there is no immutability because I can go back and adjust the nodes.
No. The blockchain data structure itself is having all that Merkle tree kind of business. So that data structure cannot be mucked around with. If you do muck around with it, it can be detected.
But how? I control the nodes,
so what? That doesn't mean anything.
I can rebuild the blockchain with a different change.
Doesn't matter, but when you compare it with the other guy's chain and so on.
Okay, so maybe I'm missing something. What other guy's chain? The private blockchain is mine.
No. Remember, I kept saying there are multiple nodes. Even in that original picture I showed you, in that export-import kind of scenario, all those organizations, which are all part of that network, will have the exact same thing. Remember, I said the single database that's replicated and that's being systematically updated. That means that there are as many copies of that database and the blockchain.
So admittance is controlled, so if Walmart is in there, Target isn't.
No, not that, okay. So we'll come to that level of sophistication later. To begin with, in the private blockchain, before 1.0 release of Fabric, once you got admitted to the network, you got to see everything in that network. And then people started complaining, saying, oh, Walmart doesn't want to see, or the other way around. Yeah. Walmart doesn't want other guy to look at.
Participating player in the private blockchain will have same data structure.
As of now. But we'll now introduce the notion of a channel, which is like a Venn diagram within this set of nodes, whereby subsets of the nodes can have their own private blockchain, private database, and private smart contracts.
But how will they comply then with the...
So all the things that were said before apply within a channel. But the benefit is you can be part of this network and get identity and all that just once, and you can be part of multiple channels. And dynamically also you can go in and out of these different channels and so on. So think of Venn diagram where you have overlaps. So that's what a channel is. And so there are differences between how the channel concept has been implemented in the Fabric versus how Quorum by JP Morgan implements it. And I'll get into that.
Intersection, you are following the same protocol.
But you still have disjoint sets of everything, even at the intersection. So I might have a channel with you, and I have a channel with Vasudha. And so my transactions and the blockchain and the state database between you and me are separate from the one I have with Vasudha. Yeah, we will get it to the details later.
Just time check, only 12 minutes left for you.
Yeah, I know. So I should probably... What?
How do you prevent rogue computers from coming into this network?
Rogue can still be there, but then they'll be detected. And this is no different from bad actors in the case of Uber, Airbnb, and so on. You just boot them out because they have to be part of the network before they can participate. And so that's the benefit of knowing the identity and all that. Because people, so the way I phrase it normally, the likelihood of Byzantine behavior is a lot less in this kind of a scenario than in an open blockchain. Yeah, there can still be some bad actors, just like in the case of Uber, Airbnb, and so on. I said literally people try to get away with murder and things like that, but sooner than later they'll be identified and appropriate measures will be taken to kick them out of the system and things like that. Exact same thing. Let's, yeah.
Just quick question. So there's still a concept of proof of work in a private blockchain, correct? But it's less rigorous than a public blockchain proof of...
There isn't a proof of work in this case. There isn't. So there is an ordering service that I'll get into, which is the one that adds new blocks.
So do you guys want proof of stake or something like that?
No, we don't. That's my just answer. I'll tell you in a bit exactly what we are doing. Okay, good you pointed out the time check. Okay, so there are these use cases that I'll let you look at your leisure. This has to do with global trade. IBM and Maersk, the world's largest shipping company, actually formed more recently a joint venture to carry this forward for production deployment. It had been going on for more than a year now, the experimentation. Dubai is big time into blockchain. They're actually competing with Abu Dhabi. This number is no longer correct. I was at a conference in March. The head of the unit came, and it's now end of 2021. They want to become paperless with respect to all government-related work. The way things happen there is you prove your identity with biometrics. Once you do that, all stuff about the fact that you are eligible for something being given for free because of your age or monetary status, blah, 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 all that is on the blockchain. So you don't have to carry any more documents and such to get all those benefits and such. As I said, work is being done in the form of consortia. Each of the consortia has its own way of doing business. And even within the blockchain, the Hyperledger consortium, it's not like everything is standardized. There are multiple projects which are even competing with one another and so on. And the latest kid on the block is the Enterprise Ethereum Alliance. Unfortunately, what I used to say about them apparently is no longer necessarily true, which is that the work done by JP Morgan in the form of a system called Quorum. It had been announced a year ago when the consortium was formed that will be the basis for their work, but since then, all sorts of craziness has happened. So in fact, tomorrow you might hear something if you come to the blockchain track, because in my panel, there'll be a person from Intel. He says he's now got permission to say something. The actual announcement will happen at the consensus conference in the middle of May in New York as to what the real thing is that the enterprise Ethereum Alliance is going to be based on. So this just shows you there are various approaches with respect to the algorithms used to decide when new block of transactions can be added. The so-called consensus layer, that's proof of work, proof of stake. IBM and its partners used to use PBFT until the latest release, which is the practical Byzantine fault-tolerant algorithm that Barbara Liskov and company did at MIT eons ago, which is a variation on an algorithm that Leslie Lamport had developed originally. This set of things keep expanding and all that. And a lot of the performance problems have to do with that, as well as the fact that willy-nilly anyone can participate in the open blockchain. There is no way to even find out who are the current participants in the bloody network, which is all mind-bogglingly inefficient at various levels, ignoring all this hoopla about democracy, this, that, and so on. With respect to also the smart contract itself, the language in which you can write it, the execution environment and all that varies from system to system. And with respect to the database, also the same sort of story. In general, what all this means is, if you look at it in a more comprehensive way, there are many architectural features in these sorts of systems where different choices have been made by different systems, and there is no proper rationalization of the choices made and the justifications and comparisons and all that. There is a paper that tries to at least catalog what the features are of these different systems. I highly recommend you go take a look at it. Also, there is now a paper with 22 authors that has been written on the Hyperledger fabric that gives you a nice picture of what the heck is going on. Since the question was, since somebody made the point, in fact, Alex made the point. It's all just distributed databases. Guess what? I can spend many hours discussing how replication is done in traditional database systems versus how it's done over here. Here is a cryptic listing of the different approaches that are being used, because of which performance can be much better in a traditional database system, but it doesn't have the property of multiple people having to agree before a step is taken and all this kind of song and dance that we go through in the case of the blockchain way of doing business. And that's the bottom line also, which is concurrency control is not what determines when multiple transactions compete with one another as to in what order those transactions get executed. This ordering service or this guy who wins the competition, which I didn't realize was even worse than I thought it was, which is this whole business of the ordering guy even takes into account how much the transaction fees are. I was completely unaware of this. This is really throwing a monkey wrench. It makes me feel even worse about open blockchain, that you can be denied service forever just because you are being stingy about the transaction fees that you're offering. And so much for fairness and all that. And he didn't even point it out as a problem until somebody asked the question. Mind-boggling to me. So this is the benchmarking work that was done at National University of Singapore. They've come up with similar things to the TPC benchmarks, but it's the first piece of work for private blockchains. But the exact details don't matter in terms of their conclusions, because even though they started out saying private blockchains, they compared two open blockchains, Ethereum and a variant on it called Parity, with the Fabric 0.6 release. But they are working on enhancing it, and they have a framework whereby you can plug in any other blockchain system also. You already heard the history. From Bitcoin came Ethereum. It still has a lot of the problems of Bitcoin. It also started out with only proof of work, so as bad in terms of performance as Bitcoin. I don't know where Alex threw this number of, what did he say? 10 seconds per transaction as the response time. I don't know where that comes from because proof of stake is still being considered for implementation. So the 10 minutes for a transaction is mind-bogglingly slow for people who are used to, with TPC, less than 2 seconds for 95% of the transactions was the requirement for TPC-B. And of course, during the .com era, the Web 2.0 guys, not .com era, the Web 2.0 guys made it like tens of milliseconds. So she is going to now come in and do her thing.
You're applying mature market expectation to a brand.
No, I said this even before. I said this before, that for the kind of export-import kind of scenario, what we want to do is reduce something that might have taken many days or weeks or whatever. Yeah. That's why even I had my head straightened out, because when I first heard about this whole blockchain thing, I'm like, do I even want to spend my time looking at it, kind of thing. And then I was straightened out by saying, look, all this reconciliation, this, that happens in the traditional way of doing things with haphazard development of individual node software and so on, will be far improved with the use of blockchain. But still, I still want to compare to some extent to put people's speculative minds at rest, to say that don't imagine in the near future this thing will be replacing your New York Stock Exchange or NASDAQ kind of transaction systems with this.
Can we say that, like now, according to what you say, you are actually enhancing a day-to-day application and adding this core of blockchain and Hyperledger fabric? Can we say that?
Well, Hyperledger fabric itself is, with the blockchain data structure and everything. I mean, it's not like it existed before this thing came up. It was actually done as a,
So the example, the use cases you showed, like the Walmart example and the global trade system, so all of that can still be done. I mean, it's not about like digitizing the paperwork and avoiding it. So like blockchain, it brings the trust in that system. What else?
it brings with it this idea of more carefully tracking. See, this is like saying, oh, Turing machines are good enough to write any program. Why do I need anything else? That cannot be the kind of question that you can be asking. So it's the protocols and the systematic way in which things are being done, leveraging cryptography, this, that, certificates and so on. That is the value add compared to, as I said, even what traditional business process management systems and workflow systems have done. So it is the set of technologies that have been combined together that makes it interesting. It's not like, I can't take existing database systems and code up all this stuff as application stuff on my own. That's besides the point. This is like saying, who needs SAP? I could have implemented all that myself, right? So, yeah.
I don't think technology is a problem here, but initially change. Right?
Well, so that's why I pointed out, it's not like you can just roll in the software and suddenly, without anything else being changed, you can benefit from it. You do have to rewrite your existing apps if you are trying to re-implement your existing application using this technology. But if you are starting from scratch, then you don't have that legacy problem to deal with.
Remember in during the late 2000s, a company like Commerce One invented B2B companies, claimed to be a marketplace, everybody comes in, right? And they want to solve the whole world's problem. But nobody really went to it, and it just died. And I'm worried, I mean, I'm not worried, I'm just speculating because the initiative change, the ROI, everything.
But that's why, in fact, the slide that I didn't show you, which is a nice slide actually, which shows what the different approaches are that are being adopted. For instance, in the know your customer scenario in Canada, the Canadian banks themselves didn't want to sit around and do this work. They farmed it out to a company called SecureKey, a startup that's doing the work. There are other approaches also. Some of them are trying to do it in a more democratic way, where all the participants sit around a table and agree upon what the terms of engagement are, hence drawing up the smart contract, if you like, in a collective fashion. And there are others where somebody like Walmart or one of these dominant players will say, hey, jokers, you minions, I'm going to determine what the smart contract is, and you shall just follow what I write and run it on your nodes, which is still better than, I've dealt with a company now where they're helping supply chain for Apple. They're just using Excel spreadsheets.
Yeah.
They've added a bit of logic on top of it. Yeah.
Yeah, I have one question. You mentioned that you have a lot of problems with Ethereum, public blockchain. But you could still run Ethereum as a private blockchain, correct? And you'd still have this.
But you still, if you don't fundamentally otherwise change it, I mean, this is like saying, oh, I'll add to, by the way, that's what, okay, so that's what this enterprise Ethereum alliance is.
Oh.
Let's go to that. How are we doing?
So I think it's almost noon. The question really is, when do you guys want to eat? I can do it while you guys eat. I can show you a demo.
Yeah, let's do
Yeah,
that.
yeah.
Eat something.
Yeah, so maybe you finish up and then you guys can go grab food.
Oh, that's a great idea. Okay. So,
The lunch is right outside. You can-
but not yet, not yet, not yet. Don't let them loose. I haven't gotten my time. Yeah.
So would this private blockchain be able to use the hardware that's used for all this mining hardware for the public ones? Are you able to?
There is no need to.
So you don't even have a need to use
Yeah,
all the
yeah,
mining
yeah,
assets,
yeah, yeah.
all the
By the way, I've been asked to give talks at KLA 10 Core, at AMAT, Applied Materials, and so on, because they're all chomping at the bits to think that they can make a lot of money making the kinds of things that TSMC has made with all this ASICs and so on.
need to that kind of
I mean, that's a mind-bogglingly inefficient, energy wasting and all that. Okay, so as I said, the Enterprise Ethereum Alliance is trying to take Ethereum to the private domain. And as I said, to begin with, it appeared like this, what was developed for internal use by JP Morgan called Quorum is what is going to fuel this EEA. But there's been chaos on both sides, JP Morgan side as well as the EEA consortium itself. As a result, over the last year, it wasn't very clear what the heck is going on. JP Morgan, meanwhile, has made available this Quorum by itself with that branding on the Microsoft Cloud and things like that. The way it works very quickly is that they, across the network, still have a single blockchain, even when you have this channel kind of notion. But instead of that channel concept, what they have are public states, which are all in all the nodes. And then they have these private state, which are these colored ones, which are only in a subset of the nodes. And the way this thing works, in this single blockchain, for everything that's in the public state, all the details are present. Whereas for the data that relates to the private state, they have only the hashes. What this means is, unlike in the case of the fabric, what is in the blockchain is the whole history of state transformations for all the assets under management. And the state database is merely the cache of the latest state of all those assets. And hence, the state database in the case of the fabric, if you just nuke it, you can reconstruct it by just going through the blockchain from the beginning to the end of the blockchain. Whereas here, you cannot do that with that private state because they don't have the full details of the data in that private state in the blockchain. In the interest of hiding it from the non-members of that private part, they decided not to put it, which is kind of counterintuitive. And as a result, if this gets nuked, the only way for its state to be reconstructed is to talk to one of these other guys who has it. Which, the way the fabric works, they think that's not cool. Because somebody, when you go ask them for the latest state, they could monkey around with it and give it to you, and you can't independently verify. So this goes back to your question. Whereas the blockchain itself has all the protection of this hash, this, that. So you can start from the beginning, which is, of course, inefficient, reconstructing. Imagine in a traditional database system, you create a new copy, and the way you're going to do that is to go to day 0 of this database's existence in wherever it started, and then having to roll forward the whole thing. That can take forever. You might never catch up, because meanwhile, the damn thing is evolving, right? But that's the way it's done today. So there is, even in the private blockchain world, the Mohan kind of people would like to see more practicality coming into the picture. Your smart contract would go and screw up this whole state, right? This is like traditional database applications where the new version of the app was full of bugs. It clobbered the database. What do? Before we install the new version, we take a backup. And then if the new app does screw up things, we do a point-in-time restore. And then we have amnesia about what transpired between that original point and the end of the log. That is considered anathema by the blockchain people, right? This is like erasing that portion of the blockchain that is the one where bugs cause problem. But you have to deal with these things. These are real practical issues, right? Anyway, so this is what the quorum way of doing business is. It still has many of the shortcomings of the, yeah.
You said that if you mute that private one, you copy it from another node.
There is no other choice because the blockchain doesn't have the details.
Right. But if they do muck around with the one you copy from, then that won't be part of the chain, right? Because there are other nodes that have that.
Well, but it's a question of now having to talk to all of them and do the compare and all that. That's the, you cannot do it independently is the point.
Right.
Yeah, yeah. Okay, but also remember, it's enough if you get the hash of the last thing because that's supposed to be cumulative and all that, that Merkle tree thing that Alex talked about, which is easier to do with the blockchain data structure than it is with the state database, because the state database is like any other database. It doesn't have necessarily all this fancy stuff in it. Okay, Hyperledger, I already told you there are many projects, blah, blah, blah. Modularity was introduced in version 1 by having this concept of channel being introduced, whereby even within a network, you can have subsets of the people being kept, being able to keep their things private compared to the rest of the people in that network. They also introduced this notion of certain nodes being the ones where the smart contracts are installed and other nodes being merely state change trackers. So maybe you'll do analytics on them, but they don't have the smart contract even installed in them. This is another approach to improving scalability within the private blockchain. Also, there is more parallelism across channels within the across the whole network than was possible when everybody was part of essentially the same channel, which is the way to think about what was the state of affairs in 0.6 release. Also, in this release, don't ask me to justify a lot of these things. They chose to get rid of PBFT and use Kafka as the ordering service, essentially PubSub. Essentially, that means that Byzantine failures are not being dealt with as of now, but they have a pluggable architecture. So if you want, you can plug in your own consensus algorithm, and then you can deal with it. And also in the future, they plan to release a version of PBFT for this situation also, I mean, this version of the software. As I said before, there is more momentum behind all this with Oracle as well as some of the other Chinese guys joining in. So the data structure in terms of the blockchain itself is a sequential file that's pretty much like a traditional recovery log, whereas the state database with the release of 1.0 also can be CouchDB in addition to LevelDB. And then there are two very simple-minded indexes that allows you to index into the blockchain. But it's all very simple-minded for a database person. It's not even like a full-blown B+ tree. It just allows you to say, I'm interested in this item. Where are all the transactions in the blockchain that have mucked around with that item? Exactly what they did with that item, you have to go into the blockchain to figure out, because this index doesn't have value-based indexing. So here is the final story on the way the transactions execute. When the client submits a transaction, it sends it to a subset of the nodes, the so-called endorsing peers. Exactly how it decides which subset and all that is all application design. The idea is to ask these different parties to simulate the execution of the blockchain transaction and get back the read and write sets that I talked about before. And then the client compares them. And if they are in agreement, and there is an agreement specification that can be given, again, it's up to you to figure out what it means. Like, Vasudha is the most important person. She has to bless every contract. But amongst the rest of the parties that were contacted, it's enough if a majority of them agree on the outcome that they want. Such things you are allowed to specify. But we don't give you a great deal of help with respect to, what is the right thing to do in a given use case scenario and so on. Once the client is satisfied with whatever the specification says, as having been satisfied by whatever it got back as the read and write sets, it sends the transaction with all that signature and everything to the ordering service, which collects many such transactions, put them in a practically random order without even examining the read and write set. There isn't any of this, oh, I'll look at their transaction fee, all this kind of nonsense. He creates a block and then sends it now to everybody. None of these guys who had even simulated the transactions have any vestiges of that knowledge of having simulated the transaction, because that was all in memory and there was amnesia as soon as the stuff was sent back to the client. What do each of these guys do? Now everybody gets it, even the ones that don't have the smart contract installed in them. They step through one transaction at a time. They pull up the read set of the transaction, peep into their database to see, is all the data that was originally read in the same state? If so, this is the validation being successful scenario, then the right information is taken and dumped into the database. That's a successful execution of a transaction. This is optimistic concurrency control where validation succeeded. If any of the items in the read set have changed state, meanwhile, then you say this is a loser transaction, none of its updates will be incorporated. And hence, ultimately, this notification will go to the original submitter, the client, that says, hey, this transaction succeeded, that transaction failed, and so on. And the normal thing is, this is no different from traditional database transactions where you could get booted for any number of reasons. You're a deadlock victim or a crash happened and hence your transaction's completion didn't happen and so on. And normal thing is for you to resubmit the transaction. So anyway, this is what happens in this way of doing transaction execution. It's because of this lengthy nature that you are asking for consensus or approval, if you like, or endorsement. And then you are sending it to this guy. He in turn puts them all together into a block and sends it. And then you go through all this mess that in any given block, only one of the transactions which mucked around with a given piece of data will succeed, namely the very first such transaction. All the others who try to muck around with the same thing will fail because their validation won't succeed. Because they all would have read that item in the same state. And once somebody modifies that item, its state changes, and hence anybody else who had read that item, their version would have been an earlier version, and they'll fail. There was a question? Yeah?
So the ordering service is a single point of failure, right?
Well, so it's the usual stuff, you know, it's Kafka, so Kafka has the notion of backup and all this kind of stuff. So yeah, that's standard thing that is inherited from Kafka. They use Zookeeper and this and that. So, okay. So let me quickly flip through the other charts so that you know what's there. There is a difference between how this version works versus how it used to work, which required deterministic execution. Because in the previous version, which is common amongst other blockchain systems also, the initial ordering is done, and then they actually execute the transaction, which means everybody has to be doing the same thing, which means that code has to be deterministic. And hence, a lot of restrictions are placed in what you can do with your Solidity implementation, you know, what features are exposed. You can't, for instance, toss a coin, you cannot look at the position of the moon and things like that, because when different nodes do those things, they'll get different values. And hence, there's no guarantee that they'll all get the same result. And this is the paper that I referred to, 22 author paper. There are various use cases. Somebody raised the point about R3 Corda. Yes, they do support relational, but they are very specific to the financial industry. They have implemented some of the features from Bitcoin and Ethereum. So they have higher level notions in their conceptual model, if you like, compared to Fabric. But Fabric is much more general purpose. So what you call an asset and all that is your own view. You have to implement all that. There isn't this notion of unspent money and this and that UTXO and such that have been inherited by R3 Corda from the original Bitcoin and Ethereum. This picture just shows you that they even have the notion of off-chain, on-chain, and so on. Intel, meanwhile, has been working on something. You will hear from the Intel guy tomorrow in the panel that I referred to before. He might also talk about what Enterprise Ethereum Alliance latest story is as to exactly what the heck it is. This one makes use of the Intel secure execution environment that I said is not as powerful as the IBM mainframe one because very little of the code and so on can be executed under this secure execution enclave. For instance, only the smart contract can be run there. The fabric or the base platform itself is too big for them to handle, and so it has those sorts of restrictions. There are Berkeley people who are making use of this in some of the research projects. Microsoft announced something called the COCO framework. Somehow they say, it's not like they are giving you a common API across these disparate systems. They run underneath them, but without modifying all of them, they somehow say dramatically improved performance will be obtained. To me, it all sounds like smoke and mirrors. But I was surprised to find out that in Bangalore, KPMG guys are messing around with this code. Until I was there a few weeks ago, I had no idea that there is actually code available for this enterprise, for this COCO framework. But there is a white paper they put out in August. So this is the project which I'm doing right now, which I said is replacing the get, put, delete interface of the database APIs that the Fabric supports with a much more familiar and much more powerful way of doing things. Today, for example, you can't even find out what are all the assets that are in your database because there isn't a select all kind of statement available. You have to do for the get, you have to explicitly mention the primary key of the asset. Where do you find out what this primary key is all left as an exercise to the writer of the smart contract. So in many ways, this is all unbelievably primitive. There are many futuristic topics that need to be addressed that have to do with some of the sorts of things that Alex talked about. There are many others that come up in the context of this channel and this and that I talked about. Today, the single transaction is restricted to operating only in one channel. We do allow you to refer to data in other channels, but that's all not subject to that validation that I mentioned. It's like a dirty read. We don't allow a single transaction to modify data in more than one channel, which will require two-phase commit kinds of properties. There are many application design issues. Like I said at one point, this whole blockchain technology, even the private one, is at a stage where relational database systems were 40 years ago when the product had just come out. And you were left to your own devices to figure out how many tables to have, what indexes to have, what sort of ways of specifying the query might run better, and this and that. All sorts of tools that came up later were not available at the beginning. Anyway, as a result, there is scope for a tremendous amount of new research to be done, new products to be developed, and somebody asked about service offering. All the hand-holding that people did and made tons of money with SAP customization, those sorts of things are possible over here also. I forget who asked me that question earlier before the session started. If you want to follow up on all sorts of other things that I keep doing, you are more than welcome to grab the information here. Ready for food? Yeah. So you should have gone and grabbed the food before so that you could have eaten. Thank you very much.